Once you know how to complete the square, then you can apply that to graphing a parabola or a quadratic with completing of the square. And we have talked earlier in the year about vertex form for a quadratic function. That was y equals a times x minus h squared plus k, or f of x equals a times x minus h squared plus k. And when we did graph with vertex form and transformations, we found that the vertex was always the opposite of this, so it was h, and the same as this. It was opposite, same, when you found your vertex. So the opposite of this value, the same as this value. Remember, the a then tells you if it opens up or down, and it also will tell you how wide or narrow the parabola will be. We can apply that same idea here to these first examples. So if I want to find the vertex of this function, the opposite of this guy would be 7. So the one with the x, we take the opposite of it, and that gives us our x value of our vertex. And we take the same value as that. So here's our vertex, 7, 5. If you're looking at number 2, we're taking the opposite and the same. So the opposite of 8 would be negative 8. The same as this would be negative 10. This one's a little funky. There's nothing inside the parentheses with the x, because what that's really saying is x plus 0 squared minus 2. You don't need to rewrite it, but understand that if there's nothing inside a grouping symbol with the x, then it's alone, or it's with the value 0. So for the vertex, the opposite of that would be 0, and the same as that would be negative 2. So we did this in the functions unit. We are going to apply a similar idea. It's the same with a little switch to graphing and using completing the square. So first thing we can do is use completing the square to find the solutions. And we did this on the previous section. So if you are unfamiliar with how to complete the square, go back to 10.3b. But what we want to do first, remember that we are trying to solve and find the x-intercepts. So if we want to find the x-intercepts, we need to plug in 0 for y. And for most of you, you'll probably be more comfortable with, instead of putting the 0 on this side, put it on this side. So that's totally up to you, but I think if you follow yesterday's lesson, the previous lesson, it might be easier for you to understand if you put the 0 on the right side. It actually makes no difference at all. You can put it on either side. So the first thing we want to do is get rid of this 12 so that we can create a blank that we can fill in. So subtract 12 from both sides. X squared plus 8x plus blank equals negative 12 plus blank, because remember, whatever we fill in here, we want to put here as well. Now we're going to take half of b and then square it. Half of 8 is 4. 4 squared is 16, so we add that to both sides. Now this is a perfect square, so we just completed the blank to make it into a perfect square, so we completed the square. To figure out what goes here, remember we take the square root here, take the square root of 16, and bring down the sign, which would be addition. Negative 12 plus 16 is, of course, 4. We want to continue solving for x, so we take the square root of both sides. The square and the square root will cancel, and we'll get x plus 4 equals not only 2, but also negative 2, because negative 2 times negative 2 will give you 4. We want to solve for x, so we subtract 4 from the left side and subtract 4 from each of the solutions on the right side. These drop out. 2 minus 4 gives us negative 2, and negative 2 minus 4 gives us negative 6. Those are your two solutions. So those will be your x-intercepts. Find those on the graph. So we have negative 2 on the x-axis and negative 6. That will be where the parabola will cross the x-axis. Now, the one thing I love about completing the square is that you can also find the vertex very easily here. So we can, what I like to say is we can extract the vertex from the work that we've already done. If you look at this step right here, we can pull the vertex. Now this value that's inside the parentheses with x is very similar to, it's the same value as what's going on here. So we will take the opposite of that, just like we took the opposite of that. So we're going to pull the vertex out here. The opposite of that would give us -4. So the opposite of the value with the x gives us our x value. And before, if you look, this other value was on the same side of the equal sign. So we did opposite of this guy, same as this guy. But now that coefficient or that constant is over on the other side of the equal sign. So instead of doing opposite same, we're actually going to take the opposite of this guy and the opposite of this one, and that will give us our vertex. So now we can go to our graph, 1, 2, 3, 4, 1, 2, 3, 4, and there's our vertex. We don't have to do -b over 2a to find the vertex. We can just extract it from the step where we take the square root. So make sure you don't go to this step. You've got to do this step where you take the square root of both sides. And now you have everything you need to know to complete your parabola. So it's all done in one problem basically. And that's what I really love about completing the square. Let's try another one here. So this time we've got y equals x squared minus 4x minus 21. So first thing we want to do is plug in 0 for y. And remember, instead of putting the 0 on this side, let's just get rid of it, and we can put the 0 on this side. Save you a step, you don't have to rewrite it. We want to create the blank, so we add 21 to both sides. Blank equals 21 plus blank. We want to fill in the blank by taking half of b and squaring it. So half of 4 is 2. 2 squared is 4. We add it to the left side means we have to add it to the right side. So on the right side we get 25. This then factors into a perfect square. Take the square root of this guy, take the square root of this guy, bring down the sign in the middle. Now we want to continue to solve. So we want to undo this square. So we take the square root of the left side and the square root of the right side. We get x minus 2 because the square and the square root will cancel. The square root of 25 gives us two solutions, 5 and -5. Continue to solve for x by adding 2, and 5 plus 2 gives us 7. -5 plus 2 gives us -3. These are our x-intercepts, so let's go ahead and graph those on the x-axis. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, -3. Now we can extract the vertex from this square root step here. And remember, we're doing opposite, opposite. The opposite of this value is 2. The opposite of this value is -25. Whoa, that's a big number. It's a good thing that we're going by 3's instead of by 1's here. So we're going to go to 2 and -25, which will be about right here. And we're all set to draw our huge parabola here. Okay? Let's try one more. Let's look at number 6 here. This will be our last one, and then you can try the last one on your own. So we're plugging in 0 for y so we can find our x-intercepts. We want to create a blank, so we move the 9 over. Now, fill in the blank by taking half of b and squaring it. Half of 8 is 4. 4 squared is 16. If we add 16 to the left side, we need to add 16 to the right side. 16 minus 9 will give us 7. And this becomes our perfect square. Take the square root here, and the square root here, and bring down the sign in the middle. Now, we want to solve for x, so we take the square root of this whole thing and the square root of this. The square and the radical cancel. Now, 7 is not a perfect square, so it's going to give us a decimal, 2.6 and negative 2.6. We want to finish just like we finished all the others by subtracting this value or adding, depending on what the sign is here. Be very careful with your sign here. It should always match this sign here. By flipping the sign here, you will get your points will be on the wrong side. You'll get the wrong sign, so be very careful. So we get x such that x equals 2.6 minus 4, which is negative 1.4. Negative 2.6 minus 4, which is negative 6.6. So you just have to estimate on the x-axis where those will be. Negative 1.4 is about there. 1, 2, 3, 4, 5, 6.6, about there. And those will be your x-intercepts. So it doesn't make it much more difficult, except you might have to get your calculator out to do that step right there. We're going to extract the vertex from this step here, doing opposite, opposite. So the opposite of this is negative 4. The opposite of this is negative 7. So we go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. And we're all set. I'm not going to do the last one with you, but I am going to go ahead and give you the answers so that you can check your work. So go ahead and push pause here before you check your work. Alright, so when you solve it, you should get x such that x equals 3 and negative 5. And when you pull your vertex out of the step in the middle here, you should get negative 1, negative 16. So check your work, and then when we graph it, it should be 3 and 1, 2, 3, 4, 5, and negative 1 and negative 16. So this is what your parabola should look like once you're all done. If you have any questions, just simply go back to the steps and follow the steps as you're working through your homework even. You could play this video as you're doing your new homework problems.